This is our Ceph dashboard. So let's log in into that one as well. Okay. Okay. So we'll walk through of like what an admin would see after OpenStack has been configured and what a a normal user would see, right? So basically these are the access menus, and as soon as you log in, any user as soon as they log in, right, it takes you to the overview page where you can see how many instances you're using, what is your vCPUs, number of vCPUs being used, RAM, and then like that network, ports, routers, those things, right? And then here it is showing you usage of your CPU. It is used 1 out of 20. So 1 out of 20 clearly indicates that this is a soft limit uh, imposed by using quotas, and it is not a hard limit. So 20 CPU is not your actual limit. Okay, so it is just something imposed by an administrator. So this admin, even if you log in via admin, right, you see two sections. One is project and one is admin. So all the admin operations are done from the admin section, and then all the project-based access things are done via project. So generally, we would create another user, and that user would have limited access just to this tab. No admin access will be there for the user which we create, right? So we'll see that also in a couple of minutes. So here are the API access points. This will be used when you are automating the OpenStack account, right? So this is for someone who is interested in automating your cloud using Terraform or any other things, right? So if they are using Terraform or anything, so instead of controller, there would be something, a generic, domain name, like let's say controller.redhat.com, right? So that kind of name would appear here, and these endpoints can be then used to automate certain things. Okay. So let's go to compute overview. So as I already explained, the overview gives you the overall of what you're doing, and then it also shows you a brief of your utilization summary, right? So number of vCPUs multiplied by hours, it is 24.16, right? So you get a brief usage as well, that how much have you been using, right? Then GB hours, this is for your RAM. How much RAM into hours? So this is this. So this was set like 48 hours ago, so it is showing you the cumulative of that, right? So the basic things you'll get from here, and then also your instance is being displayed. That okay, this is one instance is running over here. Okay. Then let's go to the images tab. So right now we have two images onboarded into the system. So one is CirrOS. CirrOS is like a very minimal Linux of about like 14, 15 MB only, which we use to validate because it is small. So we can like perform any operation just to validate whether that functionality is there or not. Okay. And then also we have an Ubuntu image. We have not created an instance using Ubuntu image. It's just for letting you know that how Ubuntu, CentOS, Red Hat, or any even Windows can be made cloud ready and then hosted into the images section. So here you will see all various images which has been uploaded by the admin user, right? Those things you can see. Then so if you want to create a new image, you can also, there are a lot of options. You can upload from your local file system, or what you can do is you can upload via providing a image URL. So that is also possible. And then image sharing, you can control whether you want to keep it public, shared, or within a project itself. So if I mark an image private, it becomes private to that particular project. Okay. So then there are certain metadatas. We'll talk about metadatas later. Then we have instances. So as of now, I have created just one instance, and it is using the Ceph storage. So we'll see how we can distinguish between various storage systems also, right? So for some users, you would want to provision tier 1 storage, tier 2 storage. So those we'll see how it has been provisioned, right? So this is your instance, and you can take its console if you're not accessing it through an IP address or anything. You can take its console, and its console will load up into this window. since it is like I'm trying to do a port forwarding, so there is a lot of delay in the while the console is opening up. So we'll come to that. I also have, so we'll go through this first, and then we'll use a AnyDesk or something to show, so that becomes faster, right? So those features which we are not able to show here, no, ISO is not the only format acceptable. So for images, all the different formats are available. So QCOW2, RAW, VMDK, all the formats are acceptable on the as an image format, depending upon what hypervisor you have. So image format is something which you will choose depending upon what hypervisor you have. So mine is KVM, so I'm using QCOW2, or I could use RAW format. But if I'm using VMware based hypervisors or Hyper-V based hypervisors, I can use VMDK or other formats, right? So that completely depends on where you want to host it.
Okay. And we can have the instances take a snapshot and also have that as an image, right? I mean, if we want
Yes,
to have some
yes.
pre-built kind of a settings to that. Okay.
Right, right. So there are a lot of options available in terms of automation. We'll go through that while we are, spinning a certain instance. So we'll spin a new instance for you, and we'll show you what all automation features are there. Okay. Then we have key pairs. So OpenStack generally doesn't support creation of your, password-based users. To keep the security, you need to create a key pair. You could like hack the system, and you could have images with pre-built username and passwords in them. So both the things are possible, but not having a password is a security advantage because anyone who is uploading certain hosting certain virtual machines with you has an has a security risk. So that's why if they are the whole sole owner of the access of the virtual machine, it gives them some comfort that okay, apart from me, nobody can have access to this instance, right? So as a security point, it adds on to the security. So even the admins, even the cloud operators who are working on your cloud don't get access to the instance. Okay. So this is the place where you create SSH key pairs. You can like create more key pairs, right? So you just need to provide a name and SSH key. So public key is kept in the cloud and private key is downloaded to your local system. So that's the end of it. It will just allow one time. Post that you cannot go to a key and say that okay, show me the private key, right? So there is no such option, right? You can delete or you can just view the public key. There is no option to view the private key. Okay, so it's kind of secure. Then we have server groups. So server groups are like when you are managing 20, 30 VMs, let's say 10 or 5 out of them are database VMs. So you could create a group because all these database virtual machines would have similar kind of security. They would want to have similar kind of performance, right? So those things can be grouped together so that you can apply operations onto them together. So changing of network, applying certain security, providing certain quality of service policies. So those things you can consider using server groups. Okay. So this is all about a compute section. So we'll go much more deeper when we go into the admin section. From a user perspective, this is all what he can do from in the compute section. Okay. Any questions so far?
Not really.
Can you come
Okay.
back again on this server group? What exactly would be the admin's role in actually controlling access over the instances or say images or any of the options that are available in the compute?
No, no, no. So you're confusing the two. So when you're creating server groups, you put various servers into that group. Okay, so when you
Okay.
have created that group and you have assigned multiple servers into that group, what you can do is you can manage them together. You means user, not an admin. You will have to create the server group, and the end user will have to create the server group, and end user will have to manage it. There is no role of admin in server groups. Okay.
So when you're saying a server, it is referring to the instances that the end
Yes,
user
yes,
would be
it
creating,
is.
right?
Right, right. It is referring to the virtual machines. It is not referring to the bare metal servers.
Okay, okay, sure.
Okay. Any other questions?
No,
Okay.
Rahul, continue.
Okay. So after this compute section, we have volume section. So OpenStack has lot many features, but these are the basic features which we have enabled, right? So those we can see here. So let's come into the volumes. So volumes are, something where you store your data, right? Even the operating system. Operating system along with your data goes on volumes. Why we keep it on volumes? We can have instances without any volumes, but those will be kind of unpersistent volumes. So as soon as you delete the instance, the volume is gone, the data is gone. If you don't attach a volume to it, okay. So that's why we create volumes and attach it to the instances for use. So while we are creating a new instance, we ask it to create a volume with it. We can go ahead and say that, okay, don't use volume. So in that case, it will use the local storage, whatever is available on the compute node. But then as soon as you delete the instance, that local storage is also deleted. So that is not persistent. So that's why anytime, mostly we'll use local storage of the computed node in very, very special cases, but most of the time we'll be using volumes to store instance operating system. When I say instance, it refers to virtual machine. So to store virtual machine operating system and virtual machine data, we'll be using volumes at most of the times. Okay. So here is how you can create a volume. So in this particular environment, I have two class of volumes. So let's say we call this one test2. So there are two classes of volumes, like LVM based and Ceph based, right? So we have two classes of storages actually. So one storage is an LVM based storage residing on a Cinder storage node, and one storage is provided by the Ceph storage cluster, which is running on our bare metal nodes with certain storage, right? So this is Ceph here. So we'll talk about Ceph in more detail shortly. But to understand this, various storage types can be provided here. So tier one storage, tier two storage, tier three storage, those kind of storages can be defined. So when a end user is creating the storage, and so they know that, okay, tier one storage is going to give more IOPS, but it is going to be charged at some extra rate, right? So that provisioning is there in the cloud, okay. And when you're creating a volume, you can either create an empty volume onto which you will input some data after you mount the volume to an instance, or you can create a volume which has a certain image in it. So why we put like image onto a volume? So let's say when we want to use the volume as an operating system disk, as the disk 0, right? So then we would create a volume with certain image. So you can specify image here, choose an image, and it will create a volume for it, right? So let's say if we do LVM type volume, so again, here we are not selected in a group. So same like now servers, you can have groups for volumes as well, again for same purpose, right? So if you want to do a group backup, a group snapshot, so those kind of things help when you have multiple groups available for the volumes, right? So that can be selected. So let's create this volume. Let's see. So right now I have created an LVM based volume, and it is downloading the image from the image store, and it is copying that image into the volume, and then it marks the volume as available. Using this volume, you can create an instance. So it will automatically use this volume and create an instance for you. Okay. So for now we'll just delete it. Okay, before deleting it, I wanted to show the backups of various volumes, right? So I took a backup yesterday, then I guess I deleted it. So we can again take up a backup. So backup can be taken for any, so this one is like attached to one of my instance, right? But still there is an option to create backup. So I can go ahead and create the backup. So let's do it for a running instance. So we can call it, okay, 0s8 backup, and we can provide it with a container name. It maybe backup one. It is not mandatory. So if you don't specify it, it will generate in normal UUID and create the backup for it. So, but just to just to have a readable thing, you can create container name as well. So right now, as soon as you click on create backup, it kind of brings you onto this screen and starts to create the backup. So right now it's in error state. We'll see why the backup is not happening. Okay, let's try to delete it.
Hey, if
Yeah.
it is in the error state, can you go in the backend and show us how do you actually debug that? Can you create another backup and let it run in an error state and
Yeah,
just
yeah.
on?
So let us walk through all the features, and then we'll go into a troubleshooting session. Otherwise, anyone who is referring to the recording will go haywire because you're having troubleshooting sessions in between and also presentation sessions in between, right?
Um,
So
okay, have it.
you can note it as a point, and then towards the end of the session, we can go ahead and try to see how to troubleshoot if some feature is not working, right? So this was about the backup, how you can create backup. Similar to backups, we have snapshots. So not to mix, backups are a lot of times there is a question that how are snapshots different from backups, right? So basically, there is no uh, there is no difference technically. A backup is also like the volume is snapshotted and then it is dumped to a backup location. A snapshot is also like point in time snapshot, right? But there is a difference in terms of how long you're going to keep that snapshot or backup, right? So snapshot is just a kind of point in time picture, and then you just let the snapshot be on the same storage, and it is again on the same LVM and those things, right? But when you take a backup, so what you're doing is you're snapshotting it as well, you're keeping it in some compressed format at some other location, so that if your primary goes down, you have a backup from which you can restore things to the primary. Okay, so that is the kind of basic difference between it. So let's try snapshot. So what I can do is like I can again. So there are a lot of options. You can manage the attachments. You can so in under manage attachments, what I can do is I can attach it to the same instance, and the volume will be attached there, right? So let's try this attach volume. So you can say automatically it will pick SDB or VDB, so that it is attached to the correct location onto the instance. So it knows that something is already attached on VDA, so I should attach on VDB. Okay. So let's try and create. So here also you can see that once a volume is created, you can even upload it directly to the image. So these are like a lot of options given. Ultimately, upload to image also will do the same thing. It will take a snapshot and then upload that snapshot into the image so that you can use it at later times as an image. So using that image, you can launch further more instances if that is what is the intent to do, right? So those things are there. So let's try to create a snapshot. So let's say we want to create a snapshot named snap 1 or snap 2. So so why it is asking me to force the snapshot? Because this instance, this volume was already attached to that instance, right? So that's why it was asking me to force. Because in if an instance is running and certain read-write operations are going through on the volumes, right? So what you need to do is you need to temporarily freeze the volume, snapshot it, and then unfreeze the volume. So that's why generally it is not recommended, because if you're running any workload, it won't be able to perform any read write for a very small period of time, right? So that's why it asks that whether you want to force the creation of snapshot. But backup is different. For backup, it doesn't ask you to do a force, because it knows that backups you would create anytime for a running instance, right? So that is how you create a snapshot. I'll just remove the snapshot. And then let's go back. We already having volumes. Let's detach the first volume. So under manage attachments, I can go and I can say that, okay, detach the volume from the instance, right? So it should detach the volume from the instance. any data or anything will still be there on the volume until unless you go ahead and delete it. Okay. So similar to servers, you can create groups here as well, so that you can apply group backup and those kind of things, right? So group snapshots, group backup, both of things you can apply when you have group of volumes, and you need to create a group and then attach certain volumes into that group. So that was about the volume section. So any doubts or any queries you have for the volume section?
For me, it's not really a doubt or something. I wanted to confirm: are we doing this as a user, not an administrator, right? Everything we've been doing is what the normal user would face when he's trying to create, like
Right,
create.
right,
Okay,
right.
okay. So
So
we are
so
not
all
yet on the side of the administrator, which is already set. We are now in as one person who's using this cloud.
cloud services, right, right, right. We have not yet gone to the admin section, but we'll go there. So after we finish volumes and network, I'll walk you through the admin section as well.
Okay.
Okay. So if there are any other questions, we can just pause for a minute, or we can continue to the network section.
Hey, I just got dropped, so I did not catch what Mancy's question was. But mine was related to for this particular backup, right? How
Mm-hmm.
does the user ensure that if one particular server of that particular volume goes down, the same, if he intends to take two different set of backups, the backups are
Mm-hmm.
intended for two different set of volumes at two different
Mm-hmm.
servers, that is. I mean,
Right,
this
right.
volume as one of 1000 GB, as was visible over there, right? It is going to be a
Mm-hmm.
summation of all the volume, underlying volume that you have been provided at the time when you were configuring it, right? So,
Right, right.
how does one ensure that the volume or the backup that is being taken is spread it across the two different servers, that is?
I didn't get your question. So you are saying that how one ensures how a volume is spread across different servers.
The backup is spread across two different servers.
Okay,
So,
so
your volume.
it's so okay, yeah, physically it is servers, but logically speaking, what happens is backup does not go to your primary storage. That's what it ensures. It means it will not be part of the same Ceph cluster if you are doing the backup. It will not be part of the same LVM volume if you are doing the backup. So like in our case, the backup is going to an NFS target.
A what?
NFS target, network file system.
Okay. So I
So,
think
you have
that's what.
set up. Sorry,
Okay,
go
okay,
on,
right.
man.
No, 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 no. I was trying to understand what you're saying because when you're having a storage, it's like the safe one. It exists across more than one server. So
Correct,
you
right.
you're wondering
Right.
what's gonna happen because it's taking data from different places.
Yeah, see, we have one server in Contabo and one in DigitalOcean, and those two servers have been clubbed up to create this particular volume, which it actually gives on the U as a 1000 GB. Say 500 being distributed between these two data centers. Now, I wanted to ask, once we take a backup, say Contabo goes down or DigitalOcean goes down, the end user is being assured that if he takes a backup, if one server is going down, OpenStack is that smart enough that okay, if one is not reachable, so logically it is clubbing them together as 1000 GB. But if the 500 GB or if the DigitalOcean is down and it is not responding back, it goes back to Contavo and then gets that particular backup from there. So that the end user is satisfied that okay, it is going to work irrespective of whatever, if there is a restart at one particular data center or one particular region, like AWS assures us. So I just wanted to be assured that okay, the end user is not going to be at a loss, because then it does not make sense if the backups, if the server in itself is not working right, if the backups are not getting pulled back again.
Did you get that, Raul?
Yeah, in a nutshell, I would say that if as long as you are taking the backup of the volume, it is available to you. No matter how many different servers or how many different centers that volume is serving, it doesn't matter. It as long as you are taking the backup of the volume, it will be available.
Yeah, but does this logic also apply? The logic whereby you can use servers from multiple sites. Like he's talking about Contabo, then is it possible that we use storages from different servers that are in different locations
So
to build safe?
different regions could point to a same backup entity. So that means like if you're backing up a volume from region one, it is going to region backup one, and then again you're backing up a volume in region two, it might be again going to region backup one. So that is possible.
Now I'm talking about building the safe.
Sorry, building the.
Safe. Can you build a safe with nodes that are in different locations that are not in the same
Right,
site?
correct, correct.
So Ceph can be multi-region, yes.
Oh, okay. And if you can, what are the measurements? Because Raj is talking about 500 on one side and 500 on another. When I doubt that it will be 5,000 plus 5,000 per hundred. It should be something like, I don't believe that it will be 500 plus 500 to get 1,000. There must be something that he's missing that I'm missing, but you could be having. When you're building a safe, what are the measurements? If I have a node that is giving 500 gigabytes and have another one in a different location that is giving another 500, how are these? These are going to produce a safe of what size?
So if you are having a node in region 1 and then having a node in region 2, both let's say 500 GB, so you would back up those individual volumes.
Before you back them up, building the safe, what is the storage capacity you're going to get out of them?
Storage capacity again will be something, whatever the administrator provides them. So if you are building two regions, then it will be 500 500. The storage will be counted as that you are using 1000 GB.
Okay, then Raj is right. Okay, so you're
Yeah.
talking about backup now. The backup should be big enough to contain more than 1,000 at that time. Okay.
Yes, yes.
So, a very generic question. This current 1000 GB that is being shown, was a complete server being provided which has this 1 TB, say, or are there different set of servers which are clubbed, say, 200, 200, 5 different servers of 200 GB? How is the current setup being done right now?
So that is just a soft limit for your account. So you can create 20 volumes of 50 GB, you can create 10 volumes of 100 GB, or you can
Okay,
create 5 volumes.
irrespective of that, what is the current volume that is being configured for this OpenStack to use?
When you say current volume means,
What is the current capacity? Say I'm creating a VM or I'm creating 5 VMs of 100
so
GB.
so
So
present
what?
capacity at LVM based storage is limited to 50 GB, I guess, 50 or 100 GB, and capacity available at Ceph is about 100 GB.
Um,
I think Raj is talking about the
actually,
participation of different hosts, different nodes. Like how many nodes are being put into place, and each one is putting how much to reach. Like the safe that has been dying, that has been failing all this time. What
yeah,
is
Right,
perfect.
right. So
Yeah, right.
how
so
is it doing
Ceph
right now? What is
Ceph
the
is
confidence?
having 100 GB per node, and is having a replication factor of 3. So that
What does that
means
mean?
the combined storage is 300 GB, but because your replication factor is also 3, it is going to provide you with an effective storage of 100 GB only.
Uh,
Uh, okay,
okay,
okay.
so if we understand it correctly, you have, say, for example, 5 different servers over which you have configured this Ceph. On 5 different servers, say you only have 100 GB of it. So clubbing it all together on a logical level, you have 500 GB available, and
No,
then it.
on a physical level you have 500 GB, but on a logical
Correct.
level the available storage will be 500 divided by 3, 133 GB.
Okay, which its replication factor is 3. Okay,
Right,
got it.
right, right.
Right.
That makes more sense. Okay.
Yeah.
Can you continue, Raj, or you have another question?
No, no. That was the only thing.
Okay, okay. So we'll move to the next section, which is networking section. So first thing which OpenStack offers you is the topology view. So topology shows you how many routers you have, how many networks you have, how are they connected, right? So this gives you an overview of how the network is being, how this network is interconnected, the virtual network and the physical network, how they are interconnected, and how the networking is flowing to your instance, right? So all these virtual networks act as a L2 switch, or I would say unmanageable switch, where you can just plug in various ports and you get the connectivity. Whereas the router is acting as a router only, but it is doing the NATing for you and can also provide firewall service for you. So you can apply security on the router level as well, right? So not enabled in at present POC, but that is a possible solution that you could enable firewall. So in case of a firewall, the router gets attached a firewall over here, and you can apply various rules on the network level. Right now, whatever security rules we are applying it on a per instance level. Okay. So this is the topology. You can have multiple external networks, you can have multiple internal networks, and those can be interconnected. Okay. Apart from this topology view, you also have a graph view, just to get a logical connection that you have one instance. This is connected to one logical network, and then this one is connected to the router, and the router is connected to the internet. So any topology view you can refer. This is for a quick view, like what is happening in my network, right? So that for that we have this network topology page, and then we have various networking options, so you can create various networks. So again, this is something which a user would see, right? So as in, the only thing the user won't be able to see is this particular entity. Because we are an admin user, we can see the external network as well, but as an end user I would just see all of my internal network only. And you can create various networks. So let's go ahead and create. So this one, let's call admin hyphen network 2, and you want to enable admin state, and we want to create the subnet. So we'll just move forward. We also have a provision to provide specific MTUs. So this is very handy when we are creating VLAN based segmentation or any other protocol which we are using. We have the capability to provide MTUs, so we can enable jumbo frames on the switch and have a packet size of 9K, and still the MTU we can control it to be 1500 or 3000, whatever required, right? So we can do that. Then we go to the subnet creation. So a sample subnet name, and then network address, you can choose anything. So even if it is conflicting with some other user's network, you can still choose the network, right? Because these are isolated from each other, and so that multiple users can have same IP schema, right? But only for their private networking piece, not for the internet facing or external facing networks, right? Then we have subnet details. So these are, we would want to enable DHCP, so that as soon as our instances are plugged in into the network, they get an IP address from the network. Second thing is we might want to have some instances where we assign static IP addresses, right? Although in OpenStack the IP address does not change once you provision the instance, because it pulls from the database. But there might be certain scenarios where you won't want to limit the allocation pool to, let's say, starting from .10 to .200, and rest of the IPs you would want to reserve for anything else, right? So let's say if every project is going to have an AD server or something like that, you can reserve certain IP addresses, that okay, these kind of IP addresses I will provide. IPs above 200 are allocatable only to Active Directory or some other instances, right? So that management you can do. You can provide static routes over here into the network. So the DHCP will distribute the static route to those instances, and you can also provide DNS name servers, right? So let's say if you leave this allocation pool blank, it will just use all the IP addresses. So from zero to not zero, from 1 to 255, right? So it will use all the IP addresses, and we can specify one of DNS name servers. So let's hit create, and it should create that network for you. Now, if you go back to your network topology view, you can see that this particular network 2, is not connected to anything, right? So, so you can see admin net 1 is here, but admin net 2 is not connected to anything else. So what we can do is we can just add one more interface to the router and say that you connect admin net 2 as well with you. So you can connect it. We have already specified a gateway, so we don't want to specify it again. There's no need. And here goes your router. So if we go back to our network topology page, we can see that now this network is also connected. You can see an orange line coming to this particular network, right? So this is how everything is shown connected, and you can use this page to create various networks and subnets. Then let's come to creating of routers. So for creation of additional routers, I would require some additional IP addresses, which we were not able to configure that day. But just for understanding perspective, we'll show how these routers are getting created, right? So we'll just call it test2 hyphen router, and then we need to select an external network. So what happens is, as soon as you create this router, it will pick an IP address from this external network. Let's see if we have any additional IP addresses or not. If we have one, yeah, so that's why. So you can see it, the quota exceeded for the. So you can see no more IP addresses are available on this network. So that's why we are not able to create any additional routers. But what we can do is, like, we can delete this router, and we can show you the how to create a router and all, right? So I'll walk you through that once we are over with the admin, and we create a fresh user just to understand how a fresh user will log in and how the user will be able to see various functionalities available. Okay. Okay, so let's go back. Let's
Hey,
look at.
Rahul, I'm actually not clear about this quota exceeded one. What exactly
Mhm.
quota was exhausted? I mean, what IP was exhausted with this? Are you talking
We
about external IP?
we are talking about the external network. Out of that external network, we were provided 10 IP addresses. Out of that 10 IP addresses, we already have used 8 IP addresses to just build the CEFS clusters, NFS servers, Openstack servers, and those kind of things, right? So we just have only, I guess, 2 IP or 1 IP addresses available, and that we used in creating one of the routers.
So the 10 IPs that you are referring to, those are the internal IPs or an external IP, external
These
pool of
are
IP
ex
addresses?
these are external pool of actual network IP addresses.
Okay, okay,
Okay.
okay.
Uh, and then if we move further, we have security groups. So there
Hey,
we can give,
sorry,
yeah.
sorry for the interruption, but for the previous part, right? How does an external IP address get allocated to an instance that gets created? I mean, like for the EC2 instances, right? We just create it, we ask for a public IP address, we get one.
Yeah, because
In
Amazon has already purchased lots and lots of IP addresses.
Correct, right. That be the case. What I intended to ask was, how does an instance get allocated that IP address? Say, for right now, for an assumption, say you have 10 set of external IP addresses in your pool right now.
Right.
So how does this particular OpenStack manage it? Because once you get an IP address being associated with this particular system, say, then what
Mhm.
exactly happens with it? I mean, how does OpenStack take care of it? That okay, this particular IP address is for this particular VM itself, for this
It
particular.
keeps tabs in the database. So when you put an IP address, it stores it in the database against that instance.
Um. Oh.
But you have a
Okay.
place where you
You
said
can
for the
continue.
10 before, like on administration side, where you said those 10 IPs in a setting somewhere.
Yeah, it's in the settings. So let me show you. If we go back to our networks tab, right? So this is our external network. So let's go to edit network. Not edit network. Let's go inside this network and we'll be able to see our subnets, right? So this is our external subnet. So this is our network, right? This is our actual physical network which is present at the data center, right? Which was provided to us to create these virtual machines, right? So now if I go into the edit subnet and I go into the subnet details, so actually we have just two IP addresses. So one is 70.24 and other one is 70.25. So that was provided to us. So I did put a request for 10 more IP addresses, but I'm not sure if that went through or not.
Mark gave them. I saw them, him giving them to you, but maybe you didn't see them.
Okay. So, Mark, can you tell me what those IP addresses are? We can add it at runtime.
They're on WhatsApp. If you go back to WhatsApp, you see a place
them
where
on WhatsApp. We share them on WhatsApp.
I read
Uh,
dot 31 to dot 40.
okay, that is nice. So, as you can see that like just now I added 10 more IP addresses, right? So this IP addresses are like slice of the actual physical network, right? So now let's say if we want to create another router, it should allow us to create the second router as well. Because as soon as I create the router, it will allocate one IP address to the router, right? Because a router needs an IP address to communicate to the external network, right? So if you go into the router and you see, so this is the IP address it got allocated, right? So again, an end user cannot see this. It's only because we are logged in as an admin, we can see all these things, right? So if I go back to the network topology, I'll be able to see that how my router is connected to internal virtual networks and how it is getting the physical IP addresses, right? So physical IP addresses are present on the router for NATing purposes. So this is, I wouldn't say natting. So in pure networking terms, I would call it patting. So all the traffic which is originating from this particular instance goes here, and the router does a port address translation and sends the packets to internet using this particular IP address 10.169.70.25. In our actual scenario, this will be a public IP. Now, because we are doing a POC and we are not using public IP addresses, but in an actual scenario, these will be the public IP addresses. Okay, so let's go ahead and any questions so far? We can then move to the security portion of it.
So this first router you have attached it both to this orange as well as green network. Is that so?
Yes.
And how does it differentiate whether an instance which is connected to the green one, right, SIR 8, or an instance which is connected to, say, the orange one, say, SIR 9 or something? How does that
Mhm.
particular IP address differentiate between which instance I have to send it to?
So instance will have its own IP address, right? So service 8 you can say is having its own IP address. So with that IP, it can distinguish that what IP an instance is having.
No, actually, I'm thinking from a perspective. Say we have a Kubernetes, we have a master one, and I'm attaching
Mhm.
that master to both orange as well as green. And now I've got a
Mhm.
public IP address as only the first one. So how does it exactly? How does the router exactly differentiate between where to send the traffic to, or does it have any heartbeat kind of a thing?
So router does a very simple routing. So if you are connecting an instance to both of these networks, the instance will have two different IP addresses.
Yeah,
So
yeah, I get that. So okay, never mind. You can continue for now.
so basically, what it will have two different IP addresses, and they both will be communicating to their respective gateways. So 172.16 series will talk to its gateway, and then 192.168 will talk to its own gateway. Does that clarify?
We're
Um,
talking about one router with two interfaces.
Yeah. Yeah. Sorry, Manzi, come again.
We're talking here about one router with two interfaces. I think
Yeah,
it's
router can have as many interfaces as
yeah. Mm.
as till the time their network is different. You can connect 10 different interfaces to a router.
Are we good, Raj?
yes, yes, Mansi. For now, we are good.
Okay, okay. So then let's move to the security group section. So in the security group, first of all, we create a certain security group. So let's say for the demo sake, let's create test two. So once the security group is created, all the traffic originating as an egress to this security group is allowed, right? So you can see IP version 4 as well as IP version 6 is allowed egress, right? So anything originating from the instance towards the internet is allowed by default. You only need to add rules for anything which is coming from the internet towards your instance, right? So let's say I would allow HTTP, then I can simply add that, or I would only allow HTTPS, I can add that, right? So as soon as I add, you can see that those rules get added to this security group, right? And where do we apply these security groups? So if we go back onto our, compute and instances, so here on the instances, you apply security group. In case when you are using firewall as a service, you would apply the rules straight away to the firewall, and it would, block traffic on a network level. Here we are blocking traffic on a instance level. So let's say here we want to change the security group. So as soon as you change the security group, you can apply test to and remove allow all, right? Or you can apply allow all as well, and then you can apply test to as well, right? So you can apply a combination of multiple security groups, and then it is implemented in a top to bottom order, and it is applied to the instance. So as of now, both HTTP and HTTPS traffic will be allowed, and then from the second rule, all TCP and UDP traffic will be allowed to that instance, right? So this one we use for testing only, like where everything is allowed. In actual production, we would limit the traffic to SSH and HTTPS only, or those kind of things, right? For the servers which are facing the internet, so we'll use those kind of things. So, and you can click save and it will apply that particular security group to your instance. Okay. And you can like add, keep, once the rule is applied, still you can add more, security group rules into it. So even though the security group is applied to an instance, you can, let's say security group is applied to 10 instances, you can simply add a rule to that particular security group and it gets applied to all the 10 instances. So you don't need to reapply. Okay. So this is how we create security groups, and then let's okay. So this is attached to an instance. So for now, it won't allow me to delete that particular security group. So if a security group is attached to an instance, it won't allow you to delete it, right? So I'm just modified it to allow all, and then we can simply go ahead and delete this particular security group. Then we go to floating IPs. So floating IPs are something. So one IP you can see it went to the router, right? Where router needs one IP address to do a port address translation for all the traffic which is originating for the internet, right? Then similar to that, you might want to have a direct access to your instance for n number of reasons, right? You want to host something, you want to have direct connectivity to the instance, n number of things, right? So for that, you need to allocate an IP. So this is only possible if you have like some number of IP addresses available, and these IP addresses should be part of your physical network, right? These are not virtual IP addresses. So you allocate an IP address, and then once the IP address, so you can see now 38 has been allocated. So if I associate this one to a particular instance, so let's say 0 is 8, so we can just associate it, and then I can access this instance from the, uh, I can access this instance from the internet. If it would have been an actual public IP address, I could use this IP address and SSH into my instance from anywhere. But right now, since we are doing a POC, so I guess for now I can like access the instance via the hypervisor or within the POC environment, I would say. Right? Any questions? Okay. So so this is all what we have in terms of from a user's perspective. Then let's proceed to the admin section. Okay. And then release floating IP address. So I'm just releasing the IP address back to the pool. So let's go down to the So we'll just minimize the project and we'll move on to the admin section, right? So admin section is, it provides you, kind of specific information around the environment, right? So right now you can see, this is the overview of the project. We just have one project. If we have multiple projects, all these projects will be displayed over here. So details about all the projects are provided to the admin, and admin can also query its usage from here and get a reporting kind of thing from the OpenStack cloud, right? So and this can be done for like n number of projects, or if you want to query it for a specific project, that can also be done, right?
And does OpenStack have any particular plugin, say, if we have some cost effectiveness or cost attached to that particular usage of it? So, say one particular project is using these many things, so it gets multiplied by say $1 or $0.5 or something. So,
No,
does
so
OpenStack?
OpenStack does not provide you pricing as a service. It does provide you rating as a service. So where it allocates some amount of CPU or some amount of RAM, it maps it to units per hour or units per second, but it will not map it to dollars per hour or dollars per second. So for that, we need to have an external billing system. So OpenStack doesn't provide you with a billing system. It provides you with monitoring. It keeps track of these resources, that how many CPUs, how many RAM have been used for how many hours and so on. But it doesn't provide you with a billing system where you could say that, okay, now you multiply this with the US currency and or maybe Indian currency and give the output in INR or USD, right? So billing is not present with OpenStack. Okay. So then, any questions so far? Okay. So then, moving forward, what we have is Mansi, do we have any time constraint or something like that?
Personally, I don't, but it depends on you. You can ask, how much time do you have? How much time do you need? Personally, I'm
Yep.
going to go up to the end because I'm recording anyway. So whoever's going to
Okay.
miss it is going to come back later. The issue comes with you. For me, it's important that we go up to the maximum we can get today. Unless if you say we close something today
No.
and we do it tomorrow. What do you say?
So from my end, we don't have, like, at least I can go ahead for 1 more hour, if that is fine with you guys. If not, what we can do is we can after a certain time we can break, and then we can you know redo it tomorrow morning, whatever is comfortable with you.
Gentlemen, what do you guys think? I need to hear. I don't want to force everybody to be there.
Oh, it's almost 7, so maybe it will be better to close up maybe in the next, I don't know, like 20 minutes or something, 20 more.
And we
That's
continue tomorrow.
personally the way I see it. Yeah, of course.
Okay. Richard? Oban? Okay. I think let's go. I'm getting something from Marvel. Maybe the others are the
Hello?
same. Maybe they're not even following because we didn't. Mark, what do you think?
Okay. Yeah, I think we can go for 20 more minutes. Yeah,
Any question?
actually, I think most of us didn't know how long this presentation was gonna take.
Yeah, it's
So
true.
I think we can go for the next 20 minutes up to 7. Then maybe we can continue tomorrow morning. But one other thing I wanted to ask is, this presentation itself is not enough. If we can have like a proper documentation, so that one can actually go through it in a calm manner, not rushing to try and understand everything. The presentation itself is good, but we need like a proper documentation as well for everyone to go through, because I don't think we'll be able to exhaust everything through the presentation.
Right, Raul? Does that make sense to you, Raul? For example, we don't know the
Yes.
configuration matters, how it is configured. We ask simple questions here and there, but it's true, be good if there was a document. actually present to us. It would have been good actually we had that document before we come to this presentation. Now I
Yeah,
feel
so
up
yeah,
for
so
it.
as Max said, right? So basically, if we talk about individual operations and go through it, right? It is an exhaustive list. So what I can do is like maybe I can give you a procedure based to do basic activities like create an instance, create a network, create a router, um, associate, connect the router to the network, then connect the instance to the router, SSH your instance, those kind of things. Create security group for instance. So maybe a basic thing we can provide you, but then other things, the environment is there, and you can like it's a POC environment. It is built so that you can play with it. So you can go ahead and try things on the cloud and on the environment, and look out for yourself like what is working, what is not working. Come back to me on the chat with various questions like, okay, I tried this, this was not working. I tried this, this was not working. So maybe you will get a better idea.
Yeah, but where does a person get the exact configurations that are in place right now? Apart from what you know, can we see that through some interfaces here? Is there any place I can
No,
actually tell exactly?
you'll have to go go through the CLI and check configuration for like all the individual components. And I would personally not suggest you to do that because it's again an exhaustive list, right? So there are like 10 components having at least 3 to 4 subcomponents. So it is like 30, 35 components, and then for each of the 35 components there is a configuration file, and each of that configuration file has like many options. Now we are using some subset of that options, but I'm not sure how well you will be able to grab it, because it takes like for me also it took years to, and years to get the
Yeah,
meaning
so
of what each line
you
is
create a
saying.
design, right? An overview design of how you put some component together. Like we have the nodes, how the set is made up of
Yeah, those
the
those basic things I guess like we have we can put it in an Excel, and we can show you that okay, this node is having this component, this node is having this component. At least that we can provide you in an Excel, not an issue.
Let's finish this tonight, and then whatever you have as a documentation before we leave, you give it to us, and then we meet again tomorrow.
Okay. So we'll tomorrow cover the admin and self storage. For now, let me see if you can. Uh, are you able to see the Excel sheet which I'm presenting, Manzi?
Not yet.
Where did we share it?
I'm okay. Hold on. Let me. The Excels, what I can do is I can provide you in the same group so that everyone within the group will have access to it, and then meanwhile tomorrow I'll have my Skype fixed so that I can at least show you guys all the things, right?
All right.
So let's continue. So one of the core things which I wanted to show you is also the Ceph storage. So again, Ceph UI is also exhaustive. So basically, as an cloud administrator, you don't want, you would not want to like go into the Ceph dashboard into details. So basically, the overview is screen is what you would want to visit. So as you can see that client throughput is one of the figures you want to see, that how much read write operations are going now on the Ceph cluster, and the number of IOPS which it is passing through. So we just have one very small instance which is using Ceph, so it is like it is using very less. So right now you can see it has paused, then again after some time it will just do some small operations. Okay, and then you can see the raw capacity. So I was initially there was a question like how much storage is available within Ceph, right? So raw capacity is 600 GB. That means we have three instances, and on each of these three instances we have 200 GB, 200 GB, and 200 GB. So that is our raw capacity. And so we have used 1.4 GB out of that raw capacity, and we have like 598 GB of capacity still available. And And then other thing which you would check in a Ceph cluster is the number of OSDs. So how many OSDs are there and how many of them are, up and are in use within the present cluster, right? So those things you would want to see. But again, as an administrator, like not as just as a cloud administrator, you would just come to this overview screen, go through the screen and be done with it. And after that, any for managing Ceph and all, you need a hardcore dedicated storage person, because at times the Ceph cluster itself is a vast domain and it gets very complicated if you are not managing it in the right way. If you are managing it in the right way, it is very easy to use. It can be scaled up to n number of levels. It offers petabytes of storage, and it has this nice GUI through which you can monitor things, and it will tell you the number of hosts which is there. So basic information you can grab from the dashboard itself. But if you want to still deep down about like how many hosts are there, so you can see Ceph 1, 2, 3 is there. How many physical disks are okay? So orchestrator has not been configured, so it is not able to tell you the number of disks, right? How many OSDs are there? It should be able to tell you, right? So those are things it will tell you how whether monitoring is configured or not. How many pools are there? So pools is again kind of logical constraint over the self storage. So like in any storage system, we have number of pools, right? So you can see. So basically, for OpenStack, we are using Sender, Glance, and Nova pools. All of them are like into three replicas, and then these are something which are being used internally by Ceph. So our Rados gateway is like used to provide S3 capabilities as well. So that functionality is also enabled. So this storage will also act as a S3 storage for you. So similar to AWS S3, you can use Ceph for S3 capabilities as well. So when you configure it with in integration with OpenStack, you can provide Swift based S3 storage, which is again based on your Ceph storage, and then same Ceph cluster is responsible to hold the data of virtual machines, volumes, and everything, right? So that way, you just need to manage a single Ceph cluster, which is like fault tolerant and highly available. So it can manage a failure of n minus one nodes. So if it is a three node, it can manage a failure of one node. If it is like six nodes, it can manage a failure of two nodes. So likewise, n minus one node failure, it can tolerate. And then it offers like block storage is there. You can use block storage, you can provide ISKC. NFS based storage is also there. So all depends on configuring. For our OpenStack usage, we just needed RADOS block device functionality. So that's why we didn't implement all these, right? So object storage is also there. You can use it as an S3 based storage, which we did enable. You can see how many buckets and all are there. So right now there is only one test bucket which we created. So we'll look through these things in more detail when we talk about Ceph into more detail. And then what else? Okay, cluster is there, pools is there. Basic things you get from the dashboard itself. The number of IOPS, throughput, and all. Yes. So one more thing which I wanted to show you in terms of now which is not part of admin section. I'm purposely avoiding the admin section so that we can start afresh with the admin section tomorrow. And hopefully I'll have a separate user configured for you so that you can differentiate between the storages, right? So let's create a Ceph volume. So we want to keep the type as Ceph so that it goes to Ceph. So Ceph I just kept for understanding. You can like do tier one, tier two, so that the end users would not know like what is running at the back end, but you could categorize it as tier one, tier two, and those kind of things, right? So once you start creating this volume, it is there in Ceph. So now if you go to Ceph, so you can see that client throughput has raised to 1.1 Mbps, right? Very high. means not very high, but high in terms of its average uses, which is in kbps, right? So now it is down to zero because nobody is there using that volume. Just when it was downloading the image to that volume, the throughput went high, right? So as soon as you create more and more volumes, it will consume storage here, and you can see, from used your used capacity is still about 1.5 GB only. So Ceph has the capability to do deduplication. So if you are storing similar kind of data, it will do deduplication. So it is not necessary that if you are having 200 GB of data to store in a Ceph cluster, it would require 200 GB at the Ceph cluster. It would do deduplication, compression, and then based on that, the amount of storage will be less. So I guess some people dropped from our call. Manzi, you can still hear me?
Yeah, I can see and hear you guys. It's true. I'm seeing people dropping. Yeah, but they
Yeah.
believe what you're gonna do in the next 5 minutes, they'll see it on the recording. So, and I also
Yeah.
sense also that because you know you're gonna continue tomorrow, you're going around the same point. So we can also stop this here and then continue tomorrow because even you, I'm sensing that you are scared to start another subject right now.
Yeah, because if we start going into the admin section, then it will again take up an hour or something. So basically, I want to start, so for people joining tomorrow, I want to start afresh with the admin section so that everybody is on the same page.
Is there anything we could be reading between now and tomorrow so that you may follow you easily, or it is a normal thing as what you just saw right now?
So sorry, come again. I just missed your point.
We need to read anything before we come to see you, something we need supposed to be familiar with. We
No,
don't.
I guess not required. So basically, for the what I can do is I can give you the link. All the documentation, because it is open source, it is already available on the open source, right? And the documentation is huge. But what I can do is I can give you one or two specific links to which you can go through, like how OpenStack components are distributed, how OpenStack networking enables talking within various compute nodes, or talking towards internet, right? So basic understanding, so that you get to know that, okay, when it is talking towards internet, it use this route, and create at the back end, it creates some Linux bridges and Linux networking namespaces, and that's how it talks.
That's okay then. Yeah, I think we can then postpone and meet tomorrow. I will try to get from the WhatsApp group the base time and communicate to you.
Yeah, sure,
Could
sure, no worries, no
base time
worries.
for you tomorrow?
Yeah, so when it is morning for you, I guess it is already second half for me. So once you guys are up and you're comfortable, you can just let me know your time and we can start at that time.
Like 1:30 your time?
Yeah, it will still work.
Let's consult internally and see what's possible.
Okay, okay, sure, no worries,
I know
Manzi.
most people will be good between 12 and which will be 3:30 for your time, but let me get from the others.
Sure, 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 sure.
I appreciate very much, Raul. Thank you very
No,
much.
no worries, no worries.